Thank you for joining me today. My name is Hannah Lathom, and I'll be presenting on the analysis of hemoglobin concentration in nursery growing and finishing gilts to be used as breeding replacement. Anemia is generally defined as the decreased amount of red blood cells, or hemoglobin, found circulating in the blood. Hemoglobin is important because it is known to bind oxygen and transport that to the tissues. In swine, anemia is not new. In fact, it has been reported in the literature since the early 1900s. Modern pork production practices have emphasized the amount of anemic swine found in the herds. Such practices include the more prolific sows bred, the increased individual growth rate of piglets, and the movement to rearing of swine indoors. Clinically, it is known that larger piglets are at a higher risk of developing anemia at weaning. Anemia does not only affect suckling and weaning aged pigs, it affects sows and gilts. Those with anemia are seen with higher morbidity and mortality rates, and on farm can be seen as unthrifty and pale. There's currently no known data on the hemoglobin status in late nursery and finishing pigs in North American swine herds. While there has been numerous studies on the neonatal piglets, weaners, and sows during gestation and lactation, there is a knowledge gap on the hemoglobin status of replacement gilts. Additionally, hemoglobin concentrations are not often taken on farm due to the lack of the reference intervals needed to interpret them from the producers and veterinarians. Therefore, the objectives of the study was to primarily examine the effect of hemoglobin status of the replacement gilt at selection and placement, and the subsequent reproductive performance in the first parity. Secondarily, we wanted to gain relevant parameters of hemoglobin levels in the early and late nursery and finishing stage of the replacement gilts. Moving away from our project background and into the project design, this is a longitudinal study composed of 600 gilts from a single multiplier herd. This flow is located in eastern North Carolina. All variables were assessed with Pearson Correlations. Timeline of our study goes as follows. All gilts were placed at 3 weeks of age from the same sow farm onto the same nursery. At 4 weeks of age, enrollment occurred and the first hemoglobin was taken. The second hemoglobin was taken at 9 weeks of age, followed by placement of of the gilts onto the finishing farm. 15 weeks of age was the third hemoglobin concentration. At 26 to 27 weeks of age, selection took place on the farm, followed by the final hemoglobin concentration at 28 weeks of age before the gilts moved to their sow farms. The study used 10 grams per deciliter for the cutoff of anemia. This value has been used in multiple other studies of anemia in swine. All of the hemoglobin concentrations taken were determined with the HemoQ 201 Plus instrument. During enrollment, all gilts were enrolled on the same day. An individual ear tag was placed on each gilt for identification throughout the entire study. All bleeding was done from the external pinna of the ear with a simple needle prick, and that was collected into the HemoQ 201 Plus instrument. The gilts were bled 4 times at the 4, 9, 15, and 28 week of age intervals. This shows our hemoglobin reference ranges collected during the study. To orient us, at the top, we have age in weeks, the hemoglobin concentration of the selected gilts, followed by standard error mean and the number of gilts in the selected group. Then we have the hemoglobin concentration of non-selected gilts, followed by the standard error mean again, and the number of gilts in that group. Despite the numeric differences, the hemoglobin concentrations did not statistically differ between the selected and non-selected gilt groups. Overall, a trend upward was seen in the hemoglobin as the age increased from 4 to 28 weeks of age. The lowest hemoglobin concentration was taken at 9 weeks of age, and the highest was taken at 28 weeks of age. The overall gilt productivity was standard for North Carolina practices. The Pearson correlations of the study showed that there was, at 28 weeks of age, there was a small positive correlation to the number of stillborn pigs in the first litter of the selected gilts, meaning that as the hemoglobin increased, the amount of stillborns also increased. Implications for the industry is that this project discovered a connection between the hemoglobin concentration and the first parity stillbirths seen. And our values can be used for reference intervals by producers and veterinarians alike. I'd like to make the following acknowledgements to Dr. Glenn Almond, Jimmy Heisel, and Dr. Chris Olson and Pharmacosmos Inc. for sponsoring us, and Prestige Farms for giving us the facilities and pigs to use. I would now like to field any questions. Thank you so much.